Okay, there is a little chart that we are going to be starting in this lesson, and we will be building on it in future lessons as well. And so let's get it going here. It's going to be very small today because it's just this first application. We're getting it started, but the table will build to include f double prime as well, and talk about what does f double prime tell us about f. But today, this is what you need to know. What we care about f prime, the first derivative, is whether it is positive or negative. So could you tell me what positive or negative looks like on a graph? Above and below. Okay, above and below. Positive and negative looks like that on the graph. This is going to translate to increasing and decreasing for f. So what does increasing and decreasing look like? Going up and going down. So we started this like early on in the year. It was definitely first quarter, just probably like August, maybe September. But we started reviewing the concept of positive above, negative below, increasing going up, decreasing going down. And this is one of the reasons we did that, because we're now putting these two things together. So that's kind of the beginning of the chart that we'll be building. Let me be a little bit more specific about this. If f prime is positive, then f is increasing. It will be referring to a particular interval, like it's positive from here to there, so f will be increasing from here to there. And then conversely, if f prime is negative, f will be decreasing. But this is summed up in the table above as well. One more thing though, what's the difference, or what's the last thing, not positive, not negative? What's the last thing that doesn't fit in either one of those categories? Zero, right. So let's write that down. If f prime equals 0, then f is constant on that particular interval, or it's usually kind of at a point. But basically, and you're going to hear me say this word here, it's going to level off. It's not going to be going up or going down. It's going to be remaining still, remaining constant. It's going to level off in the graph. This is really the nutshell of today. And we're going to run through quite a few examples. They go kind of quick. They're not the worst, but they show this in different contexts, like different kinds of examples, like how do we apply this knowledge? Okay, so I know it's not a lot to go off of, but I am going to jump into the examples now, and you'll see how this is the knowledge that you need for it. Okay, so here's a warm up here. So we're going to look at a graph of f. Indicate the points where f prime is positive. Very much a warm-up. This is a very simple question, just getting used to this idea. And I am labeling this graph as f because that's what the problem says that it is.
The whole graph is f.
Mm-hmm. Yep, it's the original function f. This is actually a key thing in this lesson to make sure we get these right, is you have to get in the mode of what am I looking at, because you could be given f or you could be given f prime. So I'll let you finish copying that, and then I'll I'll point out how that matters. Okay. We're going to refer to the table. So I'm going to jump back to the table so we have it in front of us here. And the graph that we're given is F. What do I care about? The answer is in the table, not the bullets. What do I care about F? Increasing, decreasing. A modification that I could make to this slide actually is to actually draw these arrows backwards as well, because it does go both ways. If F is increasing, then F prime is positive. If F is decreasing, then F prime is negative. So it does work both ways. So, but the important thing on this example is noting that we're looking at increasing versus decreasing. If the question is asking for F prime being positive, what are we looking at for F, where F is increasing? And what does increasing look like on a graph? Going up. Okay, so let's start from the beginning and go from there. At point A, is the graph going up? Yes, it is. So A would be one of our points. At B, is the graph going up? We're always reading left to right, by the way, if you're unsure about that. At B, is the point going up? It is not, because it's remaining constant actually is what it's doing. It has leveled off, so not B. Is the graph going up at C? Yes, it is. And what about at D? No, it is actually going down. So the answer to this question would be A and C. That's simple. Okay, just getting going here. This is definitely not, that question definitely will not be on the test. It is too easy. It's getting us used to this idea. We are not strangers to problems like these where you have to sketch possible shapes. It's getting you used to what should this graph be looking like? What are possibilities that you can have? So we've done this before, talking about number of legs and end behavior. Now we're talking about the positive, negative, and the increasing, decreasing concept. Okay. The information that they give you is about F prime. I'm not going to jump back to it every time. Look at your table. What do I care about F prime? Positive and negative. Okay. So they give us information right here that says that F prime of X is greater than 0. What are they telling us? What is that translated? F prime is positive. So because of that, and it says that it's positive everywhere for all of the X's. So what does that mean F is doing everywhere? Increasing. Thank you. So F is increasing for all X, meaning everywhere, for the entire domain. So now we're taking it a step further and actually drawing a picture of what that looks like. What does increasing look like? Going up. So we have a few, there maybe you could think of others, but it could be as simple as a line, right? An upward going line, slope, a positive slope, right? Or you could have something with a little curvature with it. That would also be increasing, right? But then you could also have that curvature going the other way, like this, yes? It could also be a sort of a cubic situation that would look something like that, where it has a change in concavity, which I feel like we've talked about that. Do you know what a change in concavity produces? Starts with an I, inflection point, yeah. We'll talk more about that when we get to the second derivative test. But it's still increasing. Even though the concavity has changed, the graph is still going up. So these are just some possible shapes of increasing graphs. Okay, not spending too much time on the easier ones. Let's go on to example 3, which I think is kind of a turning point. Like we're kind of getting a little closer into, all right, maybe you'll see this one on a test. Shown is the graph of which one? F. And we're going to sketch a possible shape for F prime. So we're going to have a given graph, and then we're going to have an answer graph. F is the one that is given, and it looks like this. The table that we've begun is so much a lifeline in these types of problems that when you get a little bit heavier into these types of problems, some people jot it down on their test when they get it. Like in pre-calc, maybe you jot down all students take calculus, or maybe early on you jot down your 3690 and your 45 triangle, right? When you were first learning it. After that, you've done it so much you can do it in your sleep. But things like that. So this is one of those things. It's helpful to see it rather than just imagining it. Okay, so just a little piece of advice there. Okay, here is the strategy on a problem like this. It's twofold. One, what am I looking at? And what do I care about it? So first question, what are you given? What are you looking at? Yes, but what function is the parabola? F, as opposed to what? What could be an alternative? F prime. So you need to get straight. I am looking at the graph of F. Now, second question comes by looking at the table. What do I care about F? Increasing, decreasing. I don't care about the positive negativeness. I care about the increasing, decreasing. Yes? Okay, so let's translate this parabola in light of that. We always read left to right on, there's only one exception that we do graphs right to left, and you know what that is. But reading left to right, what is this graph starting out doing? Decreasing. Where does it decrease until, just so I know you know what you're looking at? 1. All right, so you got the idea here. So we are going down until 1. And then what does it do? And then it increases on the other side of 1, like so. So you need to know that that's what you're looking at. You have to know the lens at which it is that you're looking at. You're looking at F, and we care about the fact that it decreases and then increases. Because now the point of the problem is to produce a second graph, and this time it's going to be of F prime. This is going to be centered around X value 1 because that's kind of the change where something has happened there. So I'm going to go ahead and put 1 on the graph. Then we get to the point of translation. What does decreasing for F translate to on F prime? Negative. And what does negative look like on a graph? Below the x-axis. What happens after 1? It goes increasing, which means F prime turns what? Positive, which means it is now where? Above the graph. So instead of decrease, increase, we have below, above. Can I extend it a smidge further and ask you an Algebra 2 level question? What does that mean 1 is on this graph? Not an inflection, a 0. It is the x-intercept of this graph because we're switching from negative to positive, so it has to cross through, right? So 1 must be an x-intercept or a 0 of the graph. One more thing we've got to pull in because we're supposed to be sketching a possible shape of this. What you told me already, like right off the bat, you told me this was a parabola, right? And so what power does a parabola have? X squared, 2. So then taking the derivative of that, what does the power turn into? The power, 1. It turns from, can you finish the sentence? It turns from a quadratic graph to a linear graph. So we're making a line, and that line needs to be below on the left side and above on the right side, and we're crossing through at the 1. And so you get a graph, and we don't know exactly what kind of slope, what kind of flatness, steepness, whatever. We don't know that much, but we can say this much about it. That's going to be a line going through 1. Do you see how this all came together? Let me do a little color coding for you here. The decreasing turns negative. This part turns the increasing to positive. It naturally produces a 0 at 1, etc. Okay. Let's keep it going. We got a few more to go, a few more areas of growth. That was not the most challenging thing we're going to do today. This is going to give piecewise a little bit, but don't worry. This is not a piecewise graph. It's just kind of looks like it the way this is all given. The first line of this problem is a disclaimer that we in honors don't worry about as much. In AP, I almost said in non-honors. No non-honors calc. This is it. But in AP, going up, not down. We talk more about how if the derivative does not exist, that means there's a discontinuity or a corner or a cusp in the graph. We don't focus on that as much. We kind of stick to a little more like the good cases, not the complicated cases. So that first line is just a disclaimer saying that f prime does exist. So f is going to be a continuous graph because differentiability implies continuity, of course. That's a phrase we say in AP a lot, but not something you guys have to worry about. So if f prime is differentiable, then it has to be continuous. That's the implication. Okay. So I'm going to start out with some opening questions while we're finishing up here. Gentlemen, is what's at your table more relevant to what we're doing here? I don't think so. Thank you. Can we put our iPads face down too, please? Thank you. Appreciate that. That's face up, but splitting hairs. All right, so let's get straight. What are we looking at? We don't have a graph this time, but what are we given information about? No, f prime. We're given information about f prime. So look at the table. What do I care about f prime? Positive or negative? Don't care about increasing, decreasing. I care about positive, negative. Okay. Now, is this information about f prime being positive or negative? It is. It's not explicitly said positive or negative, but that's what is said here, right? So let's translate the information with some notes, and then we'll get to what we need to do with the problem. What does f prime being less than 0 mean? It is negative. And I'd like to take it a step further because I'm preparing us for the real task. What will that turn into for F? Decreasing. Very good. Okay, so the arrows kind of indicate like your thought process. This is what your brain should be doing. You should be saying less than 0 means negative, and negative turns into decreasing. Okay, now the second one is pretty easy because it's just 0, but look at the notes. This is not in the table, but it's in the notes. What does F do if F prime is 0? It remains constant, and I use the term, it's going to level off. Whatever it's doing, like, okay, so it's decreasing, but then it's going to level off for a moment there. Okay, next bit says greater than 0, which means what? Positive, thank you. And that translates to F doing what? Increasing. Very good. Next one is back to a 0 again. So I'm going to write 0, and I'm going to say we're going to level off there as well. And then the last one, what does less than 0 mean? Negative. And what does that translate to for F? Decrease. Okay. So now we have kind of a roadmap, and we need to sketch the possible shape of what F is doing. So it's going to start decreasing, and then what's it going to do? It's going to level off, and then what's it going to do? It's going to increase, and then what's going to do? Level off again, and then do what? Decrease. You can kind of, I mean, even just in my motions, you can kind of see what's about to happen. So let's get it going. We are centered around 1 and 2. That is the X values that is referred to. I didn't really mention that before, but now it's relevant. What I don't know is how high up or down on the graph it is. I don't know anything about the Y values, but what I do know is that now, okay, so now we're translating this a little different way. This you look at and say negative. This, I want you to tell me which side of 1 is it referring to? The left side of 1. So on the left side of 1, what am I going to do for the graph? I'm going to decrease. So I begin like this, just decrease to 1. What happens at 1? It levels off a little bit. So we've kind of tabled off a little bit. What is the next kind of thing we care about? The X values where? Between 1 and 2, what am I going to do? I'm going to increase. So I need to increase between 1 and 2. But what happens at 2? I level off again, hit a little plateau on that. And then this X greater than 2 indicates what side? The right side of what? 2. I'm going to do what? Decrease. And you have a graph that looks like that. So what kind of function did F end up being? Remember, I used the word linear and quadratic. What did F end up being? A cubic. Yeah, it ended up being some kind of cubic function. Good. Let's keep going. There's still more to come. Example 5. Okay, I'm going to draw this in a particular place on the page. I'll explain why after I get it drawn. This example is very similar to example 3. But Can you look back at 3 and compare what's the difference between 3 and 5? Right, exactly. What you're given is opposite. So I want to show you and just tell you that this is just a little, I don't know if it's OCD or just like me trying to like keep things straight. I always try, I'm not always perfect, so don't crucify me if I don't do this in the future every time. But I like to see F and then F prime. It kind of helps with like the table, like how we have F prime, you're going to have F double prime eventually. And so I like to see it laid out like this. So when I have a given graph of F prime, I want to put that on the right side so that I can put F on the left side. Make sense? So I'm just showing you why I'm laying it out like that. You can do whatever you want. I don't care. But it helps me also because you have to determine, what am I looking at? What is it? What are we looking at? F prime. And we'll get to that. Yes, we're looking at F prime. Follow-up question, what do I care about F prime? Positive or negative, and what does positive negative look like on a graph? Above and below. So do I care that this parabola is going decrease, increase? Nope, couldn't care less. Okay, what I care about is, where is the graph positive or negative wise? So when I ask the question, what does the graph start doing? Don't say decreasing to me because that's irrelevant. What is it doing? Positive, thank you. Where is the graph positive until? Thank you. So this is positive. And then it turns what? Until where? 4, and then it turns positive onward, right? That's what you're looking at. And I tell, like, these are fairly basic questions, but once you're on your own and you're doing this on a test, it's easy to mess these up. Okay, so I'll do my best to keep you going. We need to draw a graph of F, and we care about the X values, -2 and 4. Can I prepare us for what shape we're about to draw, though? What power does this graph have? 2. It's a quadratic. Now think about, though, the fact that we are going back to F. It is going to be a cubic. We're going up a power this time as opposed to down last time. Do you remember how last time the parabola turned into a line? This time you're looking at the derivative, so the parabola is turning into a cubic. We up a power when we're going to F. So you're about to make a 3-leg kind of a shape. What does the positive here translate to? Increasing. So where am I going to increase? Use up lefts, rights, and numbers, and what are we going to do? We're going to increase where? On the left side of -2. So the left side of -2, and again, we don't know how high up or down we're doing. I'm just going to do it there. It could be entirely, well, not entirely above. It would have to cross eventually, but it could be much higher if you wanted to, or it could be all below. Okay, now what does it turn doing? It turns going down because F prime is negative. Where is it going to go down until? Until 4. So all the way over here at 4, I crossed through the origin. That was not really intentional, but it's okay because you don't know what it's doing. And then what's it going to do after 4? It's going to increase again. Do you see the cubic equation that we just graph that we just made? Again, pay no attention to the fact that I went through the origin. It's just kind of worked out that way. Yes. It can be anywhere. It could have been all up here. It could have been all down here. Like it doesn't matter high or low. It's just the shape. And again, I point out like the fact that I crossed the origin was just happened that way. Yeah. Yes. We used 0. Let's see. Example 3. Well, like you're talking about like right there. The one, oh, because we had a change in direction. Like we did, there was something happening at 1. It's the same way that on example 5, something is happening at -2 and 4, right? Because on this one, we cared about, and I'm going to use some of these, we use words like this in AP. This one changed direction at 1. This one changed sign at -2 and change sign at 4. So it's a matter of, am I looking at changing direction or changing sign? But those are the values that we care about. -2 and 4 on this one. And on the last one, it was the 1 that we cared about because we were looking at increasing, decreasing. This one, we're looking at positive, negative. So we're looking at where does it make that change, which is the zeros. Yeah. Now, where this lesson goes from here, this is a good example to kind of segue us into this. I'm going to take away the pink. Can I? Yes. Okay. This is the segue into like the final bit here. What, and I think we've used these words before, what has naturally been produced at x value -2? Yeah, I see that. I see why you say that, but that's not exactly what I'm going for. A maximum. Haven't we talked about maxes, mins when we talked about inflection? A max has been created. What has naturally been created at 4? A minimum. And the reason that has happened is because, let's go back to this one. If you increase and then decrease, what does that create at the top? If you increase and then decrease, what's created at the top of the hill? We just said it, yes, a point, but a maximum, a max, a high point. If you decrease and then increase, what is that naturally creating at the low? Minimum. That's where this is going. Welcome to the first derivative test. That's not this lesson, but it's introducing you to that idea. So there are actually a couple more examples. Don't hate me, but we need to talk about these. Did I warn you that this is a very calculus-y lesson? Yeah. I'm going to kind of abbreviate a little bit. Positive on the interval here. We'll probably not get a chance to do example 7, but that's okay. We're going to call the lesson done because we've got the idea. We've learned all the concepts. It's just practicing different contexts. Sorry, it's a long, long lesson. You win some, you lose some. Some days are worse than others. It's when you get these lessons like this that are very conceptual, like something like quotient rule, low D high minus high D low over low squared. Like we just said, we do it, we practice it, and it's easy. But then when you get lessons like these that are a lot more, let's apply a concept, a little more involved. Okay. Let me steer you in the direction that you should be looking at in this problem. And it starts right here when it says f prime at 1 is 0. From that statement, f prime at 1 equals 0, what is the x value that we are interested in this problem? 1. You know by looking at function notation that the x value of interest is 1. If it tells you that the derivative is equal to 0 at that x value, what is f doing at that point? Constant. Yes, we're going to level off because of that. So there's going to be some kind of leveling off happening at 1. So I'm just making a little indication that that is happening. Then you have to look at the other information you're given, what's happening on the left and the right of 1. So what interval is the left side of 1? Note that those are intervals, not coordinates. What is the interval for the left side of 1? You have 2 options up there. Okay, the positive. Okay, I'm looking for the actual interval. The interval is -3 to 1, right? -3 to 1 is the interval on the left side of 1, okay? And then what you're telling me is that f prime is what? No, f prime is positive. What is f doing? Increasing. So on the left side of 1, f is increasing. Okay, let's hear me out. We're almost done. What is the interval on the right side of 1? 1 to 4. What is f prime doing? Negative. So what is f doing? Decreasing. What did you just naturally create at 1? A max. Oh, a parabola. Yes, I hear you. But it is also a local max. And that's the problem. Finish up. Yes. -3 and 1 is the left side of 1. 1 to 4 is the right side of 1. Yes, intervals are always x's. It's not, it's telling you, if I was trying to do this in a hurry, but if I'm being really specific, it would go all the way over here to -3. So it would say something like this. All the way from -3 to 1 is yes. And then it would go all the way over here to 4 as well. And it would decrease all the way to 4, something like that. But my point was what's happening at the 1. So I was just trying to get there. Yeah. But you're right. Thank you for pointing that out, though. We should be going all the way from -3 to 4. Yes.